6. Hi, Doctor. We are from Group 6, Section 10. Our group consists of 3 members, which is me, Tan Chun Xiang, Eric, and Qing Chun Gong. Today, we are going to share our project, which is fire alarm system. We have decided to design a fire alarm system which detects smoke, fire, and temperature using multiple sensors. The objective of the system is to prevent casualties and property damage. We have 3 inputs, which are fire, smoke, and temperature. And 2 outputs include water sprinkler and alarm. When one of the 3 input sensors are triggered, alarm will go off and the water sprinkler system will be activated to put out the fire.
Alright, so thank you, Chun Xiang, for the explanation. So right now, I'll explain more on the Quartus app. So as you can see on the screen, this is our logic circuit of the design. And right now, this is using the OR gate, which is the basic gate. So as you can see, we have 3 input sensors, F, S, and T, which is fire, smoke, and temperature. And all 3 are connected to OR gates. The first OR gate will result in an output of W, while the second OR gate will result in an output of A. For the output of W, the minimum expression we'll get is W equals to F plus S plus T. So on the other hand, the expression we'll get for the output of A is equal to F plus S plus T. So when one of the sensors are triggered, the output will be sent to W and A. So right now, Chun Gong will compile the design for this OR gate. Okay, so now that the compilation is successful, we'll move on to the simulation part. So right now we'll need to edit the code for a bit because of the Quartus prime problem. Alright, then we'll need to edit the overclock the time. This is 80 nanoseconds. And for S, we'll put it as 40. And for T, we'll put it as 20. Now that's done, we'll start the simulation. Okay, so as you can see, this is the timing diagram for our logic basic gates, and we've successfully obtained the same result as our truth table. So moving on, we'll do the same for the NAND gate. But before I do that, I'll run through a bit for the NAND gate, sorry. So this is the NAND gate configuration of the same logic circuit as previously shown. And instead of using the OR gate, we're using the NAND gate configuration. So as usual, we'll have the F, S, and T inputs, and we'll have 2 outputs, which is W and A. And when the first output, we'll get the expression of W equals to A times B times C. So when we apply the Morgan's theorem and we expand the expression, we'll get 2 bars. So eventually we'll get back the same output, that is W equals to F plus S plus T. So the same goes for the A output. We'll get the same result, which is also A equals to F plus S and plus T. So right now we'll compile the design circuit. Okay, now that it is done, we'll move on to the simulation part. So as usual, we'll repeat the same steps. Now we'll edit the time clock, which is 80 for the F, 40 for S, and 20 for T. Yeah, so right now we'll run the simulation. Okay, so as you can see, the first logic gate as shown just now. So because it is based on the same truth table, so it makes sense to have the same output. So before we end this discussion, we can make a small conclusion that our fire alarm system is designed to ensure the safety of civilians by preventing and putting out any fires. So by utilizing Quartus prime, we've successfully obtained our logic gates and the design. Also, after running the simulation, we'll obtain the timing diagrams, and we can conclude that in both configurations, we'll obtain the same results. And in comparison, it is learned that the basic gate configuration circuit is way easier and more manageable since it is less complicated and involves less gate compared to the NAND gate configuration circuit. So that's all for today. Thank you.